Hey, in this video, I'd like to talk to you about interaction to next paint. That's a Google Core Web Vitals metric. And there's a lot of misconceptions that we've seen around it, especially when helping our customers improve the performance of their websites. We've seen that there can sometimes be a misunderstanding with how interaction to next paint works. So let's talk about it. There's a lot to Core Web Vitals. There's largest contentful paint, there's cumulative layout shift, but we're really only going to focus on interaction to next paint. And this video is not a primer about the metric. That being said, I think it's still helpful to make sure we're on the same page. So what is interaction to next paint? I'm just going to spend a minute talking about it. It's basically the delay for a given interaction. And what is an interaction? Well, that could be a mouse click. That could be a tap, with a stylus or with a finger on a touchscreen device. And that could be a key press on a keyboard device. And how might IMP get measured in the real world? Well, here I am on youtube.com and I want to measure the IMP score of opening up the YouTube sidebar. So to do that, I need to click on the hamburger icon on the top left corner. Video has started and I'm going to hit the extension icon for Site Speed by Debugbear. This is an extension we offer and it confirms that currently there's no interaction to next paint score because I haven't interacted with the website. And I'll click on the sidebar. I'll open and close it a few times. It definitely feels a little bit laggy, a little bit janky. Let's see what the IMP score is. That's not ideal. 368 milliseconds is actually quite slow for a simple interaction. That scenario that I just went through, I feel like that's a very common or very easily understood example. You click a button, you wait for some sort of response and you measure how long that took and there's your score. Or is it? There's a bit of nuance with IMP, and that's what we're going to talk about in this video. Now, we offer a real user monitoring service, and what that basically means is our customers, they're able to include a little script into their website, and that script will monitor real user interactions and real user performance measurements that are pertinent to Core Web Vitals. And there's a funny little nuance with some of the results that we've seen in the real user monitoring dashboard when helping our customers to improve their websites. One of those nuances is around what is the interaction element. You'll get a rating, which makes sense, right? It might be poor, it might be needs improvement, it might be good. But the interaction element is the element in question that the user interacted with. And have a guess right now, what might those elements be? It might be a button, right? You can interact with a button. But would you expect it to be something like the body element? What does that mean? What about a paragraph tag? What about a header? These are elements that we don't typically see as having interactive capabilities. And by the way, just to add insult to injury, it turns out that on a lot of these IMP measurements, they were happening on fast devices, which just made everything so much more confusing. Not only was it a fast device, but the interaction happened on an element that almost sounds like a mistake, right? How can a paragraph tag contribute to IMP? Well, that brings us onto the first misconception, that is only interactive elements affect IMP. This is not true. In fact, here's our IMP results for a particular interaction on our website. And just to be clear, one page view can have many interactions, but we'll talk more about that later. And what I noticed for a given interaction, it turned out to be this random paragraph tag on this documentation page. What's the deal with that? Let's clarify that misconception. It turns out that any element can actually influence IMP scores. What really matters is the main thread work going on in the background during the interaction. If you've ever recorded a DevTools performance profile, you'll get something that looks a little bit like this. Now, the more work or the more activity happening on the main thread, the more likely it is your interactions are going to be delayed. A helpful way of thinking about it is that the work that the main thread is doing, and by the way, if main thread is a bit of a funny term to you, just do a little search for Debugbear main thread. We've got a lot of material on this matter. That's out of scope for this video, but the key thing here is an interaction. It might coincidentally coincide with some activity that was happening in the background or on the main thread. If it does, that background activity can indeed block the interaction, causing a poor interaction to next paint score. So just to put it in practical terms, if there's a paragraph element on the page and there are no event handlers on that paragraph, and I click on that paragraph element, if there was work already happening, maybe from a third-party tracking script or whatever it might be, that work can delay the IMP. At this point, you probably understand that yes, any element can contribute to IMP. Makes sense, right? Then you might be wondering, why on earth is a user interacting with a paragraph element? And I was kind of having a similar sentiment before I really understood how this stuff works. You can accidentally tap on a paragraph element. You can accidentally tap on a body, maybe when scrolling the page, for example. You can form a text selection by pressing and holding. You can make a page gain focus by clicking on a random part of the page. I do this all the time. When I'm ready to keyboard navigate through the page with the tab key, I don't always trust that the page has focus, so I'll just click on a seemingly blank area of the page. But it turns out that that click can actually contribute or would contribute to IMP. And if there was background work happening, maybe it was a bit of JavaScript, for example, that can add delay to the IMP score. That clarifies the second part of this misconception. You understand that it could be any element in question that contributes to IMP. You also understand why interactions may surprise you when you're looking at it in your real user monitoring dashboard. You understand now when you see, oh, it's the paragraph element. Okay, maybe they were trying to copy the paragraph. Maybe they were just tapping on it for whatever reason. You understand that those are legitimate interactions that are considered for IMP. But IMP stands for interaction to next paint. If you click on a paragraph and there is no paint that needs happening, then what is the browser waiting for? What is this time that is considering? There's no paint needed. That brings us on to the next misconception, which is that visual updates are required for IMP. That statement is incorrect. And I want you to take a look at this very simplified diagram and imagine a user interaction, like a click. And we'll consider these two hypothetical scenarios. One is that the user clicked on an interactive button, and the other scenario is that they clicked on an inert paragraph tag. Okay. In the first scenario, the button was interactive, so some event handlers did execute, and the browser is of course going to need to wait for that to happen before it can measure IMP. Whereas in scenario 2, nothing changes. The user performed their little interaction, but straight away, the browser can determine that, oh, I have an opportunity to render a frame, and that's the key word here. It's about opportunity. If the browser has the opportunity to do a bit of frame rendering, whether or not it needs to, that's what is considered for IMP. Or rather, that's the endpoint of the IMP metric. Now in scenario 1, maybe there's more steps to do with the frame rendering or the visual updates, whereas in scenario 2, that's basically it. The user performed their click, and straight away, the browser had the opportunity to render a frame. There was no visual change, so IMP could be measured just like that. Whereas in scenario 1, event handlers needed executing, maybe the geometry of elements for the next frame needed rendering. And by the way, if the concept of a frame in the context of browser rendering is a little bit abstract, don't worry about it. The important takeaway here is opportunity. When the browser has the opportunity to render something or to paint or to visually update the page in some way, that's what counts for IMP. Whether or not it happens is a different story. As a little bit of proof to you, let's just take a quick look at this IMP playground that we built. All I'm going to do on this page is click on the header, the H1, at the top of the page. That's it. But before I do that, what I'll do is I'll block the main thread by clicking the block the main thread button once. And when I click that, the main thread is blocked. I click the header and look at that. We get this poor IMP score. It took 2 seconds. That's definitely classified as poor. Interaction type of pointer. Okay. Interaction target. We kind of saw the concept of an interaction element or interaction target earlier. That's basically telling us it was the H1 that was interacted with, which is correct. It makes sense. But the point of showing you this is to kind of demonstrate that, look, no visual update was needed, yet an IMP score was still measured. In this example, I'll check the site speed by debug bear extension, verify that there's no interaction so far. I'll block the main thread and then I'll hit the R key on my keyboard. And just like that, the R key doesn't affect the page in any way, yet it is still considered for interaction to next paint. And look at that, it's telling us that the interaction type was keyboard. There's a very high value there for the interaction to next paint score. And we can also double check that in the interaction to next paint section in the site speed by debug bear Chrome extension. What is also interesting, if we have a look here, the interaction target or the interaction element was the button. This button has an ID of block thread. So what was going on there? Well, think about it. I just clicked the block main thread once button, and that element, that button had focus. While it had focus, I pressed the R key. I chose the R key at random. There's no significance to that. I pressed the R key, and it almost acted on that button, even if nothing happened, even if there was no event handlers. Sometimes it's helpful to take these interaction targets or interaction elements with a grain of salt and really think about what might the user have been doing, because it might just be a coincidence. The element might not really have anything to do with the interaction in question. Let's clarify this misconception that visual updates are required for IMP. It certainly isn't the case, because no visual update is needed, and really it's all about the opportunity to render the next frame. I kind of like how web.dev put it. On a page about the event timing API, which is what interaction to next paint uses, that's the API under the hood that actually gives us these durations for IMP. They describe it as when the browser receives the event, the interaction event, until it's able to paint the next frame. I think that's a pretty nice, concise way of putting it. Let's move on to the next misconception. This is an interesting one, and it's definitely something that I thought in the past. I thought that it's only the code that I write, for example, the code in my event handlers, that can really impact IMP. I did not even consider things like memory pressure or third-party scripts that I might have included on my page as well. And those are important. The screenshot on the right is somewhat interesting. It's Activity Monitor on macOS. I think it's similar to Task Manager on Windows. And it's showing the memory usage. And that spike, or that peak, that represents a bit of video rendering work I was doing. But it was happening in the background and I didn't even think about it. And when I was using a few websites here and there, they were completely laggy. There was all sorts of jank with pretty much every interaction I was doing with the page. And I think this highlights something very important. You are not always going to be in control of the things that can slow down your users' interactions. Now, unfortunately, in this case, while I was doing that video rendering work and I was interacting with these web pages, those websites, I don't want to say suffered because that's a pretty strong term to use, but those websites will unfortunately have a very delayed interactions for my particular IMP scores. Now, my page usage might just be a drop in the ocean amongst all of their other users, and maybe it doesn't really impact IMP and Core Web Vitals all that much, but it is something to be aware of. Let's dive into an individual interaction within an individual page view. And the idea is I want to show you what it looks like when you're using a real user monitoring service like DebugBear, what it looks like when the information presented to you suggests that it's actually third-party code that's responsible, just so that you can begin to pick out these little telltale signs. Here is a subset of the data for a given interaction that a user performed on a website. And we actually show IMP requests. That basically means requests that were started while the interaction was being processed. We show what network requests were happening during that interaction. And don't get me wrong, it could be that those requests are just coincidental. Maybe they have nothing to do with the interaction, but when I see an example like this particular interaction, I would say that this is a good signal that the interaction maybe led to these requests being made, and that's contributing to the overall slow IMP score. And this links back to the misconception that it's only your own code that can contribute to a worse IMP time. In this case, it looks like it's advertising or tracking scripts. In addition to showing you the IMP requests, we can also show you something else that's pretty damn interesting, if I do say so myself. It turns out that we can extract what event handlers were running as part of that interaction and display them to you. And this is another example of where my mindset has completely changed. In the past, I would have looked at this and I would have thought, okay, that's event delegation going on. You know, the developers have been adding event listeners on the body, I guess. Yeah, makes sense. But now over time, what I've started to see is actually this is a good signal that a lot of third-party scripts have registered their event handlers or event listeners on the body or on the window. And they're basically intercepting everything. And they're using this for observability or monitoring purposes to figure out what did the user click on, you know, what was the state of the DOM when they clicked on it, and do all sorts of peculiar work like that. And that's pretty much what I wanted to show you when it comes to really correcting that misconception that it's only your own website code that can contribute to a poor IMP score. Just for completeness sake, I'd also like to show you an individual interaction for an individual page view that doesn't suggest third-party code, but rather suggests first-party code, just so you can see what it looks like. And this is maybe what I would describe as the happy path when it comes to performance debugging, because when I see an on-click handler registered directly on the anchor tag, I'm like, this is probably something intentional that me, the developer, has added in, so I can now have that confidence that it is my code. And when possible and when applicable, we will also show you the JavaScript code in question that executed as part of this interaction handler. And I think that is such a cool feature. In this case, I'm confident it's my own code. I see a very intentional event handler registered on the anchor tag. It all makes sense to me. And in a real world debugging workflow, I would take this information. I would then performance profile it using DevTools and find out where the slowdown is happening and why this might be contributing to a slow IMP score. Let's recap that misconception that only your own website code can impact IMP. Turns out that third-party scripts can affect your IMP as well. We didn't talk about how browser extensions can affect your IMP. In fact, I was using a machine back in the days. It was in an academic environment, and they had all sorts of peculiar pre-installed browser extensions to deal with like safety rankings of things that you were clicking on. When you clicked on a paragraph, it would bring up this modal that allowed you to almost collect that information and put it in your like virtual journal, I guess presumably to help with coursework and homework. But the point is that those extensions were slow, as were the machines themselves. When that website looks at their real user monitoring data, assuming they have some at all, they're going to see all sorts of slow interaction scores. Because I remember every time I interacted with the page, it was very painful and very slow. That sort of stuff is outside of your control as a developer of the website, but you should be aware that it can happen. Device hardware limitations, that's, maybe a bit more of an obvious one. If the device is slow, that can also impact your IMP scores. Operating system. I have used a laptop on like 2% battery life, and I can tell you the experience of browsing the web when you have 2% battery left is completely bizarre and just different. Everything is very slow, everything is very delayed, and more importantly, that's going to affect the IMP scores for that website. Again, another thing to be mindful of. Now, for a lot of these, you can't really fix these issues. If your users have slow browser extensions and slow device hardware, then so be it. What you can do is just better mitigate against these problems by having a generally fast website where the main thread is kept available for, well, as much as you can keep it available for, making sure your work is highly optimized, yielding to the main thread by doing small chunks of work and then allowing the browser to handle other interactions which might be delayed. Let's move on to misconception number 4. IMP represents the typical interaction delay. How is IMP measured? If you get 100 visits, what ones are considered? Well, there's a bit of nuance to this, and it's not about it being the typical interaction. Unfortunately, it's actually about it being the worst interaction. So if you have a page view or a page session, that page session, when the user's using your website, there can be all sorts of interactions. There can be like 10, 20, 30 interactions for a given page view. All applicable interactions are considered and measured during that page view session, but it's actually the interaction with the worst latency that is reported as IMP. And that surprised me a little bit because it feels a little bit rough. Well, we as developers really need to be sharp if it's the worst interaction that is considered for IMP. And it's the worst interaction that is considered. However, the saving grace here is IMP is part of Core Web Vitals. And when it comes to that overall Core Web Vitals score, it turns out that it's only the 75th percentile of page views that determines the actual Core Web Vitals score. So a bit of a saving grace there, gives you a bit of leeway. And a little side note, if you do have a website that has a lot of interactions, this will be applicable to you. One highest interaction for every 50 interactions is excluded. And that's basically Google's way of helping to prevent the scenario where an outlier, a very, very high interaction, just completely skews the metrics. If you're not feeling too confident about this and maybe you hear a term like percentiles and you're not too sure, do a search for debug bear percentiles. I'm giving you the search query because it might be easier than typing in the website URL. Do a search for that in your favorite search engine. Click on the first link, debug bear percentiles. We have very in-depth documentation as to how Core Web Vitals are measured in the context of percentiles and how it all works. Lots of good diagrams and illustrations to learn from here as well. Let's move on to the very last misconception, and that is that IMP is only measured once the page is fully loaded. I remember when Core Web Vitals first came out, I just assumed that maybe they're using some sort of JavaScript to detect the Core Web Vitals score, and surely that JavaScript kicks in after page load, and I didn't really think about it too much. Turns out that IMP can get measured as and when the user interacts with the page. And whether or not that happens after page load or during page load doesn't matter. IMP is still getting measured. The screenshot on the right over here shows a very simplified view of certain browser rendering milestones. And I want you to think about something for a second. Where do those events or these milestones, where are they happening? Are they happening on background threads in the browser or on the main thread that we keep talking about? Well, a lot of these happen on the main thread. And when the main thread is blocked up because the browser is trying to load a page for the first time, guess what? An interaction that happens during that moment can be severely delayed and can contribute to a poor IMP score. Let's try and get a better sense of things with this page load simulator. In the sidebar, you're going to see a bunch of those rendering milestones that we were just looking at. They will appear once I click on the load the page button in the top right corner. In the main content area of this overall simulator, you're going to see a mock web page. And this mock web page is going to have some buttons that appear but can't yet be interacted with because the main thread is so busy. Let's just dive into it. So I'm going to hit the load the page button. And as I do that, a mock web page is going to start loading. And straight away, I want to click on those buttons. So there's the rendering milestones and they're still happening. The page is still loading and I'm clicking the add to cart button. But look, I'm getting a really terrible interaction to next paint score. It's only when the rendering milestones are all done, basically when the page is finished loading, it's only then does the interaction to next paint score sort of return to normal, if you like. Now, don't get me wrong. I'm not suggesting that all of your users are just rapidly clicking buttons, causing really bad IMP scores while the page is loading. However, it does happen. And even myself as a user, I try to interact with pages as they're loading while not actually being aware that they're still loading. This is the key thing. Your users will not always understand this notion that your JavaScript framework has to parse this, 2 megabyte JSON payload of initial data to hydrate the DOM. Your users should not and do not care about this. And guess what? If you have buttons on the page and they look like they can be interacted with, but this hydration process that I'm sort of making fun of a little bit, this hydration process hasn't completed, you're in trouble because that IMP score is really going to be poor. So it's really important to think about what information and what components, what buttons are you displaying to users? And if they can't be interacted with, should you be displaying them? The answer is it depends. Maybe unsurprising to you, it turns out that just having a generally better optimized website can really help with this issue here, where IMP can indeed get measured before page load. To help improve the situation, you want to minimize the main thread work. You've heard me say that a few times. It's totally applicable here. If you can minimize the main thread work, especially during page load, you can better mitigate against the problem of a user clicking a button, but the main thread being so busy with downloading, parsing, executing resources that you get a terrible IMP score. So you can better mitigate against it. You can also try yielding to the main thread regularly. And again, if that's a completely bizarre set of words to use in a sentence, do a little search, debug bear yield to main thread. We've got a bunch of interesting resources on this. But the gist of it is, if you, for example, have a bunch of module or component initialization scripts, and it goes something like spinner.init and sidebar.init and advertising.init, and you keep initializing these modules, during or at page load time, you might be able to better improve that scenario where you intersperse all of these calls with little API calls that allow the browser to handle any pending interactions that it was maybe waiting for, or rather that the user was waiting for. How you actually implement this and what code you need to use, that's explained when you search for debug bear yield to main thread. There are some APIs to help with this. There is a more maybe philosophical question to ask, which is, if there are buttons on the page and they can't yet be interacted with, should they be visible to the user? And it's a bit of a nuanced question because it really depends on the website. You could argue that hiding it and then showing it, that can cause cumulative layout shift, and the sudden appearance of buttons might actually be a bit jarring. So it's a difficult question to answer, but generally speaking, I believe we need to be very careful and cautious about displaying these interactive looking elements to the user when they can't actually be interacted with and you can't display a meaningful response during that load process. And finally, just a general note, use code coverage tools. Find out what code is not needed during page load, because for a lot of that code, You might be able to just discard it. You might be able to defer or delay it. You could adopt a different sort of loading pattern where you only load some of that unused code when it's actually needed. Maybe it's a subsequent interaction, which ironically can itself delay the interaction, but the fewer resources and the fewer amounts of code you ship to the user on that initial load, the less downloading, the less parsing, and the less executing of resources the browser will need to do, thereby freeing up the main thread and allowing it to respond to interactions which might be happening. Let's go over these interaction to next paint misconceptions and make sure we understand what is the correct version of these statements. Like, what's the correct version of only interactive elements affect IMP? We now know that is not the case. It is the case that all elements can count for IMP, including non-interactive elements. If the user clicked on it, if the user tapped on it, if the user did a key press while that element had focus, it's all fair game. What about this misconception? Visual updates are required for IMP. Not exactly. It's all about the browser having the opportunity to do the next paint or to do the next frame. Whether or not the paint happens is sort of outside the scope of IMP. So maybe you could look at it as, instead of interaction to next paint, is interaction to the next opportunity to paint. Doesn't sound as catchy though, does it? Only your own website code impacts IMP. Again, we saw how this isn't true. Not only can browser extensions come into play, but just the general device characteristics can come into play in terms of interaction to next paint delays. IMP represents typical interaction delay. That is not the case. It is not about the typical delay. It is actually the worst interaction for all the collected interactions for a given page view. But the saving grace here, as mentioned, is that the 75th percentile is what is considered for Core Web Vitals, so it does offer that leeway. And finally, the idea that IMP only gets measured once the page is fully loaded, that is not correct. IMP can be measured during page load. And in fact, when we look at our real user monitoring dashboards, trust me, it really does happen. Users do interact with the page during the page load process because they don't know the exact point in time at which all the network requests are done and all the main thread work is done and all the JavaScript framework initialization stuff is done. And that last point is definitely something to think about when you're running your own lab tests, basically tests you run in a controlled environment, maybe on your own machine. Don't necessarily wait for the page to load and then do your DevTools performance recording. Maybe start the recording, reload the page, and start interacting with parts of the page and find out what happens to these interactions. Is the browser able to respond to these interactions in time, or is it not? And that's it. Those are 5 IMP misconceptions that we've observed when helping our customers improve the performance of their website. Really hope you found it useful. See ya.